Well guys, in this video we are going to discuss how can we fit a linear regression line, and then how can we apply the TTest and the ANOVA, the analysis of variance technique, to test the parameter estimates. So let's start it. So this is the data of the marks of the students, and this is social media hour. Okay, so this is independent variable, and your marks in percentage, this is your dependent variable. Okay, so we want to regress marks over social media hours, right? So if marks is denoted by y and the time allocated for social media is denoted by x, then clearly we want to regress y on x, and y is the function of x, and the regression line may be y is equal to beta naught plus beta 1 x plus e. E is the error term. So we want to quantify beta naught and beta 1. How can we quantify this? It can be quantified by, first of all, we need to calculate beta 1, and beta 1, this is equal to n summation xy minus summation x into summation y divided by n summation x square minus summation x whole square. And then we would calculate beta 1, beta naught hat, and beta naught hat, this is equal to summation y divided by n minus beta 1 hat time summation x divided by n. So this is the formula. So we need some computations for these formulas. So what will be their computations? We need n, we need summation x, summation y, and x square, etc. Okay, so what we need is xy, we need xy, we need xy, we then need x square, and okay, so let us calculate them one by one. Okay, so xy can be calculated by equal to x into y, and this is equal to this xy column. Then we need x square. X square can be calculated by x to the power 2, and this is your x square column. Now we have to sum all these values up, so it will be equal to, this is summation y, and this is the rest of the summations. All right, so what we need to calculate is, clearly this is summation y, this is summation x, this is summation xy, and this is summation x square, and n is equal to 12, because this is the data from 12 students. You count them, this is equal to 12. So putting the values, we get slope and intercept. So this is equal to n is equal to 12, and summation xy is equal to 0.5, and minus summation x is 71.5 and 9, and divided by n summation x square 12 into summation x square is equal to this, and minus summation x whole square, summation x is equal to 71.5 whole square. All right, overall if we calculate it, we will get minus 3.96. Similarly, beta naught is equal to summation y divided by n, this is equal to summation y is how much? 919 divided by n minus beta 1 time beta 1 is equal to minus 3.96 into x. Summation x divided by y. Summation x divided by n. So overall this is equal to 100. So the fitted regression line is y hat, this is equal to 100 minus 3.96 x. So this is the slope and this is the intercept. Now we have to test whether they are statistically significant or not. So we have two options. We can apply z-test and t-test, or we can apply ANOVA. So let us apply them one by one. So let's try t-test. All right. So for t-test, we need t value for intercept and slope. T statistics for beta 1 hat, this is equal to value of beta 1 hat divided by standard error of beta 1 hat. Similarly, t value for beta naught hat, this is equal to value of beta naught hat divided by standard error of beta naught hat. These are already calculated. Beta naught hat and beta 1 hat is already calculated. What we need to calculate is standard error of beta 1 hat and standard error of beta naught hat. Standard error of beta 1 hat, this is equal to sigma u hat square divided by summation x minus x bar square. X minus x bar square under root, and standard error of beta 1 hat, this is equal to 1 over n plus x bar square divided by summation x minus x bar square into sigma u hat square under root. So these are the formulas for the standard error of beta 1 hat and beta naught hat. All right. So we need to calculate certain things for these computations. For example, first of all, we need to calculate predicted y hat, which is equal to 100 minus 3.96 x. We then need to calculate e, which is equal to y minus y hat. We then need to calculate e square, and let us calculate them one by one. So to calculate this y hat, we need, this is equal to all right, this is equal to beta naught hat, which is equal to this value 100, or plus beta 1 hat. Beta 1 hat is equal to this, and into x, first value of x is this. When you are click on beta naught hat, don't forget to press F4 from your keyboard, right? Similarly, when you are click on your slope, don't forget to press F4 from your keyboard as well. So this is the first predicted value of y. If you drag it, you will get the predicted value of the dependent variable phi. If you want to verify it whether they are correct or not, you should sum it. Its sum must be equal to the sum of y, 919. So let us sum them up. If we sum them, clearly this is equal to 919. So it means that we have calculated the predicted values correctly. Alright, now we need to calculate E residuals, which is equal to current Y minus predicted Y, and similarly you can drag it, you will get E. Then you need to square it, which is equal to E to the power 2, and this is the square of E. If you drag it, this is equal to E square, and if you sum it, you will get summation E square. So clearly what this value is, this is summation E square. Alright, now we need to calculate this thing, sigma u hat square. Sigma u hat square. The question is, how can we calculate sigma u hat square? Sigma u hat square is always equal to sigma u hat square. This is equal to summation E square divided by n minus k. K is the number of parameters, which is in our case it is equal to 2. One is beta naught hat, the other is beta 1 hat. So this is equal to 590.85 divided by 12 minus 2, which is equal to 10, and this is equal to 59.085. So this is your sigma u hat square. We then need to calculate x bar, and what x bar equal to? X bar is equal to summation x divided by n, and we know that summation x is equal to 71.5 divided by 12, 71.5 divided by 12, and this is equal to, okay, then you need to calculate x minus x bar, and then x minus x bar square. So x minus x bar and x minus x bar square can be calculated by this: first value of x minus mean, and mean is equal to this value. If you deduct mean from each and every value of x, you will get x minus x bar, and then you square each of these values, you will get this column, and this is x minus x bar square, and if you sum it up, you will get 47.22. This is summation x minus x bar square. Alright, now you have to use this summation x minus x bar square in the computation of the standard error of beta naught hat and beta 1 hat. Since you know that this is standard error of beta 1 hat is equal to sigma u hat square divided by summation x minus x bar square. Sigma u hat square is already computed over here. This is 51.085, and this summation x minus x bar square is equal to 47.22. If you compute it, this is 1.11. This is the so-called standard error of the slope of the beta 1 hat. Similarly, if you want to compute the standard error of the intercept, this is equal to this formula, and if you put all these values, this is 1 over n, 1 over 12 plus x bar square, this is x bar, and divided by summation x minus x bar square, this is the value of summation x minus x bar square, and this is should be multiplied by sigma u hat square. Sigma u hat square is already equal to this. If you compute this, you get 7.02. This is the standard error of the intercept. Now putting these values in the t beta 1 hat and t beta naught hat formulas, so you will get beta 1 hat divided by standard error of beta 1 hat. This is beta 1 hat, and this is its standard error, and this is the respective t value, right? And similarly, this is beta naught hat and standard error of beta naught hat. Beta naught hat is equal to this, and this is its standard error, and this is its respective t values. Before further discussion, you guys are requested to like this video, subscribe to Shaw Academy, and press the bell icon to get regular updates of this channel. So critical region is plus minus T alpha divided by 2 with n minus 1 t degree of freedom. Plus minus alpha is equal to 5% divided by 2, n is equal to 12, 12 minus 2 degree of freedom. So if we divide it by 2, plus minus 0.025, and 12 minus 2 is equal to 10 degree of freedom. So if we use t table is given by, so this is t table 0.025, this is 0.025, right, and this 10 degree of freedom. So this is the value 10 and 0.025, 2.28 is 2.28, this is t table, right? So if you want, you can increase its size. Now look at it, this 0.25 and this is 10, so its value is 2.28. All right, now you can compare this calculated value with the table value. If you sketch the diagram of t distribution, it will be something like this. This is 0, this is minus 2.28, this critical region, this minus side, and this is plus 2.28, again this is the critical region, positive side. Now look at t beta naught is 14.06, it falls in rejection region. So it means that you reject null hypothesis for intercept. When we reject null hypothesis for the intercept, it means that intercept is statistically significant. And similarly, you can see this is 3.54 minus 3.54. It also falls in rejection region, minus 3.54. So again, we reject null hypothesis for the intercept, for the slope as well, and we conclude that yes, slope is also statistically significant. Okay, what is the interpretation of the slope and intercept? It means that if there is a 1R increase in your social media hours, if you allot one more R to the social media, it means that there will be 3.54% decrease in your marks, right? And what does the intercept mean? This is the t value. We should interpret the actual slope and the intercept. Since we know that slope is equal to minus 3.96, it means that if there is a 1R increase to the social media, there will be a 3.96% decrease in your marks, right? And what is slope? Intercept means that this is the marks which has no link with the social media hours, right? It has no link with the social media hours. These marks belongs to the other factors such as attendance in the class participation, your study hours, your assignment submission, etc., etc. So this is the interpretation of the intercept, and this is the interpretation of the slope. Since it has negative sign, it means that there is a trade-off between the social media hours and your marks. If you allocate more hours to the social media, your percentage marks will decrease. Okay, so this is how to apply t-test to test whether the parameter estimate, intercept and slopes are statistically significant or not. Next, we are going to discuss how to apply an ANOVA to test the overall model whether statistically significant or not. All right, so the test statistic for the ANOVA is f, right? And f, this is equal to summation small y hat square divided by k minus 1 divided by summation e square divided by n minus k. So we need to calculate these two things, summation small y hat square and summation e square. Summation e square is already calculated. So let us calculate summation small y hat square. For small y hat square, we need y bar. So we need to calculate y bar first. y bar can be calculated by summation y divided by n. Y bar, this is equal to summation y divided by n, and this is equal to summation y is equal to this divided by n is equal to 12, so this is equal to 76.58. all right, small y, this is always equal to small y hat, this is equal to capital Y hat minus y bar, and then we need to square small y hat. We need to square it, so we need to generate these two columns. all right, so this is equal to small y hat is equal to capital Y hat, first value, minus y bar is equal to this. Don't forget to press F4 from your keyboard to make it constant. So this is y minus y hat minus y bar, so this is the entire column. Now you have to square it, each and every value. Squaring it, I got y hat square, and this is equal to this value. Now if you sum it, its sum is equal to this value. So this is what is this value equal to? This is equal to summation small y hat square. So this value is summation small y hat square. Now putting the values, small y hat square is equal to how much? 742. So this is equal to 742 divided by 2 minus 1 divided by 2 minus 1 and divide by summation e square is how much? Summation e square is equal to 590.85. 590.85 divided by n minus k, and 12 minus 2. So if we calculate it, this is equal to 742 and divide by 5.9. Overall this is equal to 12.55. So this is your F calculated value for the analysis of variance. Then we need critical region for it. So critical region for it, this is equal to F alpha with k minus 1 and n minus k degree of freedom, or this is equal to F 0.05 with 2 minus 1 and 12 minus 2 degree of freedom, which is equal to F 0.05 with 1 and 10 degree of freedom. This is new 1 and this is new 2. If we look into the F table, the F table is given by, this is the F table. This for the 5% level of significance, this is new 1, this is new 1, and this is new 2, 10, and the value is 4.96. This is equal to 4.96. If we sketch the diagram of F distribution, this is from 0 to plus infinity, 0 to plus infinity, and this is 4.96, and you can see the critical value is, the F table value is 12.55. This is 12.55, falls in rejection region, 12.55. Therefore we reject H0 and we conclude that yes, the overall model is statistically significant. So this is all about how to fit a linear regression line, how to interpret intercept and slope, and how can we apply t-test and ANOVA to test whether the parameter estimates, that is the estimated slope and the estimated intercept, is statistically significant or not. Thank you. Thanks for watching.